Have you ever wondered what tiny signal can reliably activate a powerful electrical switch, enabling precise control over large amounts of current? It is like a delicate touch that unleashes immense energy, crucial in many electronic systems. The minimum gate current required to turn on a Silicon Controlled Rectifier, or SCR, is not a fixed universal number. Instead, it is a specific threshold known as the gate trigger current, or IGT, which must be supplied to the gate terminal to reliably initiate conduction from anode to cathode. This vital parameter is primarily determined by the device's internal semiconductor characteristics and is always provided by the manufacturer in the SCR's datasheet. This gate current triggers the SCR through a clever internal regenerative feedback mechanism. An SCR is fundamentally a four-layer PNPN device, which can be modeled as two interconnected bipolar junction transistors, one PNP and one NPN. When a small current flows into the gate, it forward biases the gate junction, injecting carriers into the base of the NPN transistor. This current is then amplified by the NPN transistor, and its collector current feeds into the base of the PNP transistor. This cascade creates a positive feedback loop, rapidly driving both transistors into saturation and turning the SCR fully on. Key factors influencing this minimum current include the junction temperature, with higher temperatures generally requiring less gate current for triggering, the anode to cathode voltage, and manufacturing tolerances that cause variations between individual devices. To practically determine the minimum gate current, you should always refer to the manufacturer's datasheet for the specific SCR you are using. The datasheet will list the gate trigger current, IGT, typically at a specified junction temperature, often 25 degrees Celsius, and a particular anode to cathode voltage. For reliable operation across various conditions and device variations, it is best practice to apply a gate current that is comfortably above this specified minimum, usually 2 to 5 times IGT, to ensure consistent and fast triggering without ambiguity. It is also important to consider related parameters such as the latching current, IL, which is the minimum anode current required to keep the SCR on after the gate signal is removed. Additionally, while we need a minimum gate current to turn it on, exceeding the maximum allowable gate current, IgM, can permanently damage the SCR's gate junction. By understanding these nuances, you gain precise control over the SCR's operation, ensuring your circuits function predictably and safely. So, by carefully consulting the manufacturer's specifications and applying a gate current slightly above the stated minimum, you ensure dependable triggering for your silicon-controlled rectifiers. This meticulous approach allows you to confidently integrate these powerful switching devices into your designs, unlocking their full potential for efficient power control.